All right, have textbooks open to page 189. You had 6 problems to do for homework on page 189. You also had a few problems on page 199. We'll get there in just a second. Before we do, let's review area. What is area, Elaine?
The inside of like an object. The volume inside of a polygon. Well, shape.
Okay, I like that you said polygon. The area, the space inside a polygon or a plane figure. Okay, it's not just telling a shape, because if it's a solid shape, then the area, the stuff inside is called the volume, which is a term she just used. So volume's inside a solid figure, but inside a plane figure, the space inside is called area. We know that area is always measured in what kind of units, Ben?
Pi.
We might use pi to calculate area in a particular instance, Corey, but area is measured in?
Square units.
Square units. What kind of units?
Square units.
Square units, good. And when do we use pi to find area? Only when we're dealing, class, with a circle. What's the formula for the area of a circle, Ben?
A equals pi r squared.
Excellent. A equals pi r squared. Now remember, we said the first thing we got to do is square the r. And what does it mean when we square the radius, Luciana? Multiply it by itself. What if they give us a diameter, though?
Cut it in half.
Okay, Michael, cut it in half, right, first to get the radius, then square it, then times pi. If the radius happens to involve a 7, we could use what for pi, class?
22/7.
It doesn't happen very often, admittedly. So usually for pi we use
3.14.
3.14. And because we're using an approximation of pi, anytime we find the area of a circle, we technically need to put what, Jalen?
Approximately.
Equal. The approximately equal, the squiggle equal. Do we need to do that for our other figures? No. Those areas actually, like, we're not using approximations, we're using actual numbers. What is my formula for the area of a square, Bryson?
Area of square. A equals S squared.
Good. Not 4s. Remember, that's perimeter. Don't multiply by a 4. Multiply the length of a side by itself. Multiply side times side. What about the area of a triangle? Sam?
A equals half H. No. Half. Base and height.
Base times height. There we go. Half BH for the triangle. Remember I said either cut the base in half if it's an even number, or cut the height in half if that's an even number. Or if neither of them is, just multiply by a 0.5 or divide by 2 when you're done. For the rectangle, what's my formula? Kirsten?
A equals R.
There we go. What about for a parallelogram, Griffin?
A equals BH.
What about the trapezoid? That's the big ugly. Corey?
A equals 1/2 H times the quantity of B1 plus B2.
Excellent. It's really not that bad as long as you remember you have to do what first for the trapezoid, class?
Add the bases.
Add the bases first, because that's what's in parentheses. In order of operation says do parentheses first. Don't forget the halves on the trapezoid and the triangle. Let's take a look at the homework now. We're on page 189. And for number 1, they gave you a radius of 5 feet. And they wanted you to find the diameter, they wanted you to find the circumference, and then they wanted you to find the area. What is, first of all, the diameter going to be, Jalen?
10 feet.
10 feet. What's the circumference going to be, Bryson?
3.14 or 31.4.
Good, approximately 31.4 feet. And then what about the area, Luciana?
78.5 feet squared.
Approximately 78.5 feet squared. Excellent. Number 2, they gave you a diameter of 200 yards. What would the radius have to be, Michael?
100 yards.
100 yards. So the circumference would be, Kirsten?
628 yards square.
Good. Oh, careful. Circumference doesn't use square units. Only area does square units. So we would just say
628 yards.
approximately 628 yards. What about the area then?
628.
Well, that's the circumference. We're looking for the area on number 2. Sam?
I didn't get
That's going to be a problem. Elaine?
31,400 yards squared.
There we go. Approximately 31,400 yards squared. Look at it real quick. Remember, they said the diameter was 200 yards, right? So we said the radius was 100 yards. Class, what's the formula for the area of the circle? A equals pi r squared. Well, when you square 100, that means you multiply it by itself, correct? Well, 100 times 100. What's 1 times 1?
1.
How many zeros?
4.
And then we got to multiply that by pi, which is,
3.1.
but these 2 decimal places, class, I can cancel with 2 zeros. But I still have 2 more zeros. What do I have to do with them? Stick them on the back. 31400. So I mean, really very little actual math there. Just got to be careful with your zeros. Let's go to number 3. They give us a diameter of 18 centimeters. Ben, back to you. What's the radius?
9 centimeters.
9 centimeters. What's the circumference then? Sam, back to you.
56.62.
Oh, really, really close. Corey?
56.52 centimeters.
56.52 centimeters, approximately that. And then what about the area? Let's go back to Sam. Big ol' ugly number.
5,662.
No, Griffin?
I got approximately 255.34 centimeters squared.
Super close. Approximately 254.34 centimeters squared. Just a little bit off in your multiplication or addition somewhere. Number 4, back to Sam. 11-inch radius. What's the diameter?
22 centimeters. But inches.
22 inches. There we go. So what's the circumference, Sam?
6,908.
Should have 2 decimal places in there because 3.14 has 2 decimal places.
Oh,
So
69.08
69.08
inches.
inches approximately. And then what about the area? Griffin wants some redemption.
Approximately 383.08 inches.
Oh, it would be inches squared, but no. Jalen?
Area approximately equals 1,519.
Bryson?
Approximately 379.94 square inches.
There we go. Approximately 379.94. So just a little bit off there again, Griffin. 379.94 inches squared approximately. Number 5, to the nearest whole unit, find A, the area, and B, the circumference of a circle having a radius of 85 millimeters. What did you get for the area? Let's go back to Jalen for redemption.
For the area of
Big
number
ol' number.
5, I got 22,676.5 millimeters squared.
Oh, so close.
Bro.
Luciana?
Approximately 22,686.5 millimeters squared.
But it did say round to the nearest whole unit. So your answer is correct, but if we round to the nearest whole unit, Luciana, what does the 0.5 do to your ones digit? Does it bump it up or does it just fall off? Technically, it bumps it up. So we would say approximately 22,687 millimeters squared. What about the circumference? Third tries to charm. Back to Jalen.
Circumference, I got 533.8 millimeters.
But round to the nearest whole unit.
304.
534. Approximately 534 millimeters would have been our rounded answer there for number 5. Number 6, Joneses have a circular fence around their garden. Fence is 17 meters from the center of the garden. What? So if you go to the dead center of the garden, you're going to be 17 meters from the fence. Class, that means that the radius is 17 meters. It says find the area inside the fence and find the circumference of the fence, or the circumference of the garden. Letter A, the area of the garden. Michael.
793.646 meters squared.
No. Kirsten.
216.6.
Oh my. Ben?
For the circumference,
For the area on number 6.
53.38.
Oh my, what's our formula for area, class?
A equals pi squared.
Pi r squared. A equals pi r squared. And we said that the radius is 17 meters, right? So you have to square the 17 meters. Someone from your paper, what is 17 times 17?
69? No.
Oh,
34.
289. Should have had 289 meters squared, and then you're going to multiply that by the 3.14. Jalen?
Approximately 907.46 millimeters squared.
Well, meters squared. There we go. Approximately 907.46 meters squared should have been our answer. Sounds like our big issue is squaring the 17. We had some trouble multiplying 17 times 17, so careful there. What about the circumference? What do we use for the circumference of the circle, class?
C
equals
2 pi.
In this case, 2 pi r. Normally pi d, but in this case, since they're given a radius, 2 pi r. What is 2 times 17, class?
34.
34, and the 34 is what we'll multiply by the 3.14 to get what circumference for redemption, Kirsten?
106.76 meters squared.
Circumference?
Meters?
Just meters, right? The area inside is meters squared, distance around is just meters. Approximately 106.76 meters is correct. Questions on this? Strategy tip, okay? Let's just shoot real straight here. There's a lot of places you can mess up with all this multiplication, right? Lots of decimal thingies and carrying issues. Show your work. So if you mess it up, I can give partial credit, okay? So instead of -10, if you show me the work, maybe it could be -5 instead. Okay, so show the work just in case. Also, the more work you show, the more likely you are to get the right answer anyway. But be neat, show the work, make sure I can read it. Yes, ma'am?
What was number 4C?
For the area was approximately 379.94 inches squared. All right, turn over to page 399, 199. I don't know where I got 3 from. 199. And you had 3 problems to do, 23, 24, 25. Now number 23 again had 3 different parts to it. You were given an 11 meter radius, and wait a second, did that seem vaguely familiar? Oh, the previous exercise we had 11 as a radius. What's the diameter on number 23, class?
22
Meters. The circumference should be again approximately 69.08 meters. And the area should be approximately 379.94 meters squared. See, number 24. Diameter of 4 feet means a radius of, class? 2 feet. What's the circumference on number 24, Ben?
Circumference. 6.28.
I think you did pi r instead of 2 pi r or pi d. So you should have had double that answer that you had there. What did you get, Elaine?
12.56 feet.
Approximately 12.56 feet. And then for the area, pi r squared, let's go back to Ben for redemption.
62.8.
Well, what's the radius in number 24, Ben?
2.
What do you get when you square it?
4.
4, and we're going to multiply that by 3.14, right? So 4 times 4?
16.
Carry the 1, 4 times 1 plus 1.
5.
And nothing to carry, 4 times 3.
12.
12, so let's say approximately 12.56, and since it's area feet squared. Notice, it's almost the same answer on the circumference and area, right? It's just one is feet and one is square feet for that. For number 25, the area of that trapezoid. What did you get for that, Sam?
I got 128 centimeters squared.
Oh, you forgot the half. You added the bases to get 16, and you knew the altitude or the height was 8, but you forgot it's a half altitude times the sum of the bases. Let's cut the 16 in half, because that's the easier one to work with then,
8 times 8.
which is
64.
centimeters squared. Is correct. 64 centimeters squared. Questions on finding area? Yes, ma'am.
It's not a question. It's not a question, but somehow on number 4C, I got the wrong answer, and 24 area, I got the right answer. No.
What did you get for number 24, the
No, it's
circumference?
23. The A area, I got 379.94 meters squared on that one, and I somehow didn't get the right answer on number 4.
Oh, I see what you're saying. Number 23 was a duplicate, and whatever it was a duplicate of, you missed it the first time, you got it the second time.
Yeah.
Good.
I don't know.
All right, at least you got it right one time. All right, questions on area. Clear your desk except for a clean sheet of paper and a pencil. Clear your desk except for a clean sheet of paper and a pencil, and everything else away. I think we are pretty much ready for this. We know our area formulas. We'll remember to use square units. We'll remember if it's a circle, so we have to use pi to use the approximate symbol on our answer. Clean sheet of paper, pencil, eraser, always a good idea. Again, you may show your work on the paper. Those watching video, make sure you submit the paper that the work is on along with the actual quiz. Okay, so I need to see the work so that way if you get the wrong answer, I can give you the partial credit. There is not a lot of room to work on this actual quiz, so more than likely you'll end up working on your cover sheet. If you do here in the classroom, obviously I'll collect that from you. This is quiz 18. Quiz 18 that we are taking. First and last name in the name spot, and today's date in the date spot. First and last name in the name spot, today's date in the date spot, it is 12/13/23. 12/13/23. Bless you. All right, let's take a look at the quiz together very quickly. Numbers 1 through 4, you're just going to write the correct formula, really straightforward. And then for the rest of the quiz, you're actually going to find the area. Notice we got some scale drawings there. Pay attention to the scale, particularly on one of them. Okay, make sure you use the formula. Keep your work covered with the cover sheet, and of course, if you need to use your cover sheet to do some work, that's fine also. All right, you may begin. Keep your eyes on your own paper. You're using your cover sheet. Ben. And about 2 more minutes to be finishing up. 2 more minutes. Just a little bit longer to be finishing. Go and collect those from you at this time. If you would, go and take your textbooks and turn to page 194. Page 194. And we've been talking a lot about figures that you can draw on a flat piece of paper, like squares and triangles and trapezoids and circles. But you know, there are some shapes you can't actually draw. You can try to represent them, right? For instance, if I wanted to draw a box, right, it's possible to give the illusion of a third dimension. You could use some of this little interior lines. You kind of get the idea of, okay, that's supposed to be a box, but at the end of the day, there is not an actual box coming off the chalkboard, correct? These are called solid figures or three-dimensional figures. That's what we're going to look at in our last little section that we go over leading up to our exam. Page 194 shows a number of different three-dimensional figures. What we usually call a box, you see there in green class, is technically called a rectangular prism. Say that with me. Rectangular prism. Now, if you jump over 2 more, you see a purple one. And that's called a, say it with me, triangular prism. Again, triangular prism. Really, a prism is just a solid one shape that stays the same throughout. For instance, I could draw, roughly speaking, a pentagonal prism. And it would be something like that. Okay, you'd have kind of that same basic, right? You get the idea of a pentagon that just stays steady throughout. A box has one shape at the end that just stays steady throughout. The triangular prism steady throughout. And the ends of a prism, if you'll note this, are called the bases. The bases of a prism are the ends of the prism. Okay, so the bases of a prism are the ends of the prism. And so we see on the rectangular prism is we see a couple of ends, so to speak. The triangular prism, right? We've got the idea here of a triangle that goes throughout. Well, this back here and this forward here, right? If you can kind of get the illusion, those are the bases of the prism. And of course, a cube would be a prism as well. We see that a cube is the same, but it's special. The cube is the same all the way around, right? Squares on all sides. Each side, if you will, of a prism is called a face. You see that term there in bold just above table B. Mark that. The sides are called faces. Okay, so a cube would have how many faces, class? 6, right? How many have played a game that involves dice? Okay, you roll the dice, okay, 6 sides. They're usually marked with dots, but 6 sides, 6 faces. Okay, the same would be true of a box, right? We've got boxes over there on the floor. We've got the bottom of the box, the top of the box, and the 4 sides of the box. 6 faces. What about the triangular prism? Look at that little purple thing there. How many faces does it have? 5. It has a triangle on either side, right? It has the bottom of the triangle, the bottom of the thing, the base, and then it's got the 2 angled sides, so 5 total faces. Okay, so a prism is got that steady shape that carries throughout. A pyramid, on the other hand, comes to a point, and what we see there, that tealy colored thing, is a square pyramid. You know why it's called a square pyramid? Because the bottom is a square. And then you have 4 faces that are triangles that come up and meet at a point at the top. So that means that the square pyramid has how many faces total? 5. Now in this case, the base would be the side that it's sitting on. Okay? And then you have the 4 angled faces, the 4 triangles. A cylinder isn't a prism because it's not made of just faces. It has a base, a circle at the bottom. It has a circle at the top. Picture a can of beans, right? Got a circle on the bottom, circle on the top. And then it's just one continuous piece that wraps all the way around, correct? Have you ever peeled the label off a can of beans? What shape is the label? It's a rectangle. Technically, you could think of a cylinder as 2 circles with a rectangle that wraps around it. A cone, like ice cream cone, or traffic cone, but that's not as much fun. A cone has a circular base, and then it comes up to a point. But it's not triangles, it's just one continuous weird piece that sort of wraps around. It's not a shape we would recognize. And finally, a ball. Class is called a sphere. Okay, so we see these different things there. Let's go back to the prisms for just a moment, though. Those are going to be the first things we're going to focus on. I guess you could include the pyramid in this as well. They have edges, right, where the faces come together, right? This desk, right, has this edge right here. And an edge, if you've ever bumped an edge, how many of you have ever seen the tearing a paper trick? Put on the edge of paper, tear it down that way? I'm not going to do it with your quiz. That's the first paper I see available. I'm like, I better not tear their quizzes. But anyway, we'll tear the piece of paper. Okay, thank you. So anyway, with the trick is if you need to tear a piece of paper, you don't have scissors or something, lay it along the edge of the paper, of an edge, and just pull straight down. You get a nice, smooth cut. Now, that wouldn't work super well on your desk because you have a little bit of a rounded piece here, so that way you don't hurt yourself on the edge. How many have ever backed into the corner or something of a wall or a counter in your kitchen or something? It can hurt, okay? So they round the edge of the student desk to protect the students. Anyway, I don't know. Back in my day, we had razor blades. Oh, just kidding. It wasn't just kidding. We didn't have that on the edge of the desk. All right, but anyway, so the edge is actually referred to as an edge. Right? Nice, easy term to remember there. And where the edges come together, this is what actually hurts you, right? And you can tell people have bumped into it a lot because it's actually worn off. I don't know if you can see that, those in the classroom. But apparently bunches of people have bumped into it because it's worn off. That would be a vertex. And the vertex is the point where those edges come together. And you see those terms there on that diagram. So, got all those different things. Let's look at that table B again, class. A basic box is referred to as a
rectangular prism.
Okay, saying this along with, make sure we have good posture here. If the box is the same on all sides, we actually call it now a cube. All 6 faces are congruent squares. If we have 2 triangles at the ends that go consistent, throughout, we would call that a
triangular prism.
Triangular prism. Almost kind of looks like an old-fashioned tent, like most tents nowadays people use but the stereotype tents that you would have seen or played with growing up. The pyramid that you see there is called a square pyramid, right? Think about the pyramids in Egypt, right? You studied that in history, basically elaborate tombs, right? But they're really big and a lot of people died building them. Anyway, the can is actually referred to, class, as a cylinder, right? They have more picture closer to a tuna can, right? Because it's shorter. We're used to the bean cans that are taller. If it's got a circle at the bottom and it comes up to a point, cone, and then the ball is called a sphere. Very good. Now, with all these different 3-dimensional figures, one of the concepts we want to talk about, we kind of alluded to one of them already, volume, right? How much stuff fits inside. We want to talk about the outside of the box. For instance, Christmas is coming, right? How many of you actually know how to wrap a present? How many say, I've seen it done and I may have even tried, but I can't wrap a present to save my life? It took me a long time to figure it out. My mom showed me. It took me a long time to get good at it. I'm actually pretty decent at wrapping presents now. At least I feel like I am, the present is covered and it doesn't look awful. It still doesn't measure up to how my mom can wrap a present. I feel like a fail. Anyway, gift bags, amen? Gift bags. Now, apparently, though, they've even, just to give people like me an inferiority complex, they've come up with the proper way to put the tissue paper in so it looks pretty. Why can't we just jam the tissue? So I try to make it look pretty, right? Make sure that you can't see the present to actually take out the tissue paper so there's some semblance of opening the gift. But big fan, big fan. There's also decorative boxes. The box is already beautiful on its own.
Yeah.
And so what I do is I save the decorative boxes and I will put the presents in there so I don't have to wrap anything. But anyway, decorative boxes are the way to go. Bows, I know how to do that. Double-sided tape, stick the bow on. Bows I can do. Okay? Wrapping the present took a while. But if you wrap a present, the idea is the entire surface of the box is supposed to be covered, right? We're talking about what's called surface area. Picture the box, right? There's the top of the box. Well, that's a rectangle, right? There's a certain area of that rectangle. But then you got the side of the box. That also has an area. The bottom of the box. The other side, the other side, the other side. Right? There's sides all over it, 6 of them. You have to cover all 6 sides. That's what we call surface area. The area of the surfaces. And so for our, I shouldn't have erased the box. That was not smart. So for our box, okay, we've got a certain length to the box, right? If we're just looking at the side of the box, it's coming off the chalkboard at us. We look at the box, there's a length across the bottom. There's also a height that comes up, correct, to our box. There is what we might call the depth or the width of the box. If we kind of look at it at a bit of an angle. And of course, there's another height there. There's another width there. There's another length there, right? We've got widths and heights and lengths and all that kind of stuff, right? Well, we understand this, that this side of the box, the front side of the box, has a length times height, right? But that's still the 2 dimensions, right? We say length times width. Well, for this particular side of the box, it's length times height. And the area of this is length times height. But on the back of the box, do you see it back here in the back? That's also a length times height. Well, I don't want to figure a length times height and have to figure another one. I'm lazy. Just multiply by 2, right? Also, if you look at the top of the box, there's a length here and the width here. Or the bottom of the box, right? Length and width. Well, each area of the top and bottom is length and width, but there's 2 of those, so that's 2 lengths and widths, right? And then we also have this side here, the ends of the box, the sides of the box, so to speak. Got the front and back, sides, top and bottom. Well, that's a width times height, but there's 2 of those. So we would say that for a box, to find the surface area, you basically put these, multiply these 2 dimensions, double it, these 2 dimensions, double it, and those 2 dimensions, double it. Seem pretty easy? So if the box is, let's just look for instance at the example on the next page, example 5.5a. They say that the length of the box is 8 inches. They say the width or the depth of the box is 4 inches, and the box has a 6-inch height. Well, again, there's this big old long nasty formula, but it's really easy to use. Start with the bottom of the box. Class, the bottom is 8 by 4. Class, what's 8 times 4?
32.
But double it because there's also a top, so we get 64. All right, let's take the end of the, let's take the front of the box, right? This height is also 6. It's 6 on the heights, right? 8 times 6, class, is 48. But there's also a back of the box, so double the 48. You can work it out on paper, can you do? 96? Hey, some of us don't need to do it on paper. And then we've got the ends of the box, right? That's 4 by 6. Well, what's 4 by 6? 24, but double it because there's also another side over here. 48. And you just add all the numbers together. Let's see, 4 plus 6
10.
plus 8, 18. Carry the 1. 1 plus 6
7.
plus 9, 16 plus 4. So apparently 280 was inches, and it's still area, class. So it's still square units. 208 inches squared, and we see that answer that they got there. Does it make sense how to find the surface area of a box? Yes. Now, let's suppose, though, that we were, maybe the box is a really big box, and it's this classroom. And several years ago, we put fresh paint on the walls. You can tell it's been a little while, okay, been a few years. But we took down all the chalkboards, we moved everything off the walls, and we painted all the walls. I say we as if I had anything to do with it. Mr. McDonald and a couple other people got all the walls painted. I was busy teaching summer school. All right, so anyway, but they painted all the walls, right? Now, they only painted the walls, not the floor, not the ceiling. At least the goal was to keep it off the floor and off the ceiling, right? If you only look at the sides, which this doesn't work for wrapping presents, okay, you do need to cover the top and bottom. But if you only are concerned with the sides, lateral always has to do with the idea of sides, right? Sideways pass in football is a lateral, right? So the lateral surface area, if you'll make a note of this, and I think you see that term on page 195, lateral surface area, or sometimes just referred to as lateral area, only deals with the sides of the object. So for instance, in the triangular prism, right? You wouldn't be concerned about the bottom. You wouldn't be concerned about the floor of the tent, but the front and the back drapes and then the two sides coming down. Okay, that's your lateral area. For a pyramid, okay, not the bottom of the pyramid, but the 4 triangular sides would be lateral areas. Does that make sense? It just means the sides. Well, the bottom of the box is the length and width, right? So lateral surface area just doesn't care about the length and the widths. Make sense? So it makes sense then that for a rectangular prism, lateral surface area would be 2 width heights and 2 length heights, but not the 2 length widths that are the tops and bottoms. We know what you do. I already got my answer, right? I don't need 64 of it. Take 64 off real quick. What do we got? 144. 8 minus 4 is 4, and 20 minus 6 is 14, so 144. And it's still square units, because it's still area. So lateral surface area is really easy to find. You just don't have to worry about the top and bottom of the box. Does that make sense? Now, what about a cube, though? Think about a cube. Cube, what's true about the length, the width, and the height of a cube? Pretend that's a perfect cube, okay? What's true about the length, width, height of a cube? They're all the same. So instead of differentiating length versus width versus height, we could just say this, class. We could just call each length the length of an edge, right? It's the same anyway. We just say this is an edge of the cube. Well, the front is a square. And how do we find the area of a square? Side squared, right? Not 4S, that's perimeter, but side squared. Well, since the side is actually the edge of the cube, we can say edge squared, right? So the front is edge squared, but how many, if you turn it, how many total sides are on the cube? 6. And they're all exactly the same, right? So we could say that the surface area of a cube is simply 6e squared. E squared is one surface, one face, but there's 6 of them. So 6e squared is even faster. So for instance, you look at they don't actually have a cube on there. Let's suppose we have a cube, and let's suppose it's a 5-inch cube. It's a little box about, so big. You see little gift boxes about that size. Not sure what you put in them, but there's sure something. Okay, 5 inches. Well, if it's 5 inches all the way around, 5 squared, class, 25. And then multiply, think money, 25 cents a quarter. 25 times 6.
250.
Careful. 6 quarters is how much money?
150.
6 quarters is $1.50, right?
Oh, yeah.
$1.50. Did you say that? I just didn't hear you. I'm sorry. $1.50, right? So 150 inches squared would be the surface area. Well, what if we had a cubicle room, right? Or a little cube and we only wanted to paint the walls? That's not surface area class, that's lateral surface area. If you're only dealing with the sides class, that's called
Lateral surface area.
lateral surface area. And so for the lateral area, well, I'm not concerned about the top and bottom, right? So how many sides would I have to deal with? Only 4 of them. So it makes sense that lateral area would be 4e squared. Does that make sense?
Yes.
Just because there are only 4 sides. Well, again, the edge is still 5, right? So 5 squared is still 25, but times 4 class would be 100. So we'd have 100 square inches of lateral area, 150 in surface area. Do you understand the difference between surface area and lateral area?
Yeah.
Right? Lateral area, just the sides. Surface area, the sides and the top and bottom. Okay, questions on that? No. Let's see here. Look at the example 5.5. Oh, we already did 5.5b. We already did it. We just had inches. There was just finding lateral surface area. Okay, we already done that down. Turn the page. Page 196. There's the cube. I knew there was a cube on here. It would help if I looked at the lesson plan. Example 5.5c. I have it down here. They give us a cube, and this cube is 9 centimeters on every single edge all the way around. Okay, so if we want the surface area class for a cube, we use the formula SA equals 6e squared. Okay, so we start by squaring the edge, class. 9 squared is 81. And then we got to multiply the 81 by 6 to find the surface area. 486, and it's centimeters squared. If we wanted just the lateral surface area class, we use the formula LA equals 4e squared. Because again, we don't care about the top and bottom now. We'll take the same 81 times 4. 324, right? 32 with a 4, so 324 centimeters squared. Seem easy enough?
Yes.
All right, so we've added 4 more formulas, but here's the thing. I don't want you necessarily to think, oh, this is such a long formula. Just think logically about what you're doing, right? Just think I'm finding rectangle areas. There's just different sizes of rectangles, right? So we got all these different rectangle formulas. So you can close your books for now. And just about that, maybe that scratch sheet of paper you were using for a cover sheet earlier, get another sheet of paper out. Let's take a look at, for instance, the food drive boxes. Okay, you remember the food drive boxes we had in all the different classrooms? Okay, the food drive boxes were 18 inches by 14 inches by 12 inches. And I believe this is the height, this is the length, this is the width, okay? So we're 18 by 14 by 12, okay, was their dimensions. Let's find the surface area if we were deciding we want to wrap this box. Now, we wouldn't wrap it if it was full of cans because it'd be really hard to get it off the ground. Anyway, we're going to wrap a box and deliver it as a present, okay? For the surface area, what we're going to have to do is pair up 2 of the dimensions and then double it because there's 2 length widths, right? So my SA equals, if I say with me, 2LW plus 2 WH, sure, whatever, plus 2, what's the only pair we haven't used yet? LH. It doesn't matter which order you pair them in, as long as you put an L with a W once, a W with an H once, and an L with an H once, right? So pair them up, double them. At your seats, find the surface area. Why do those food drive boxes have to be so big? Yeah, that's what the juniors and seniors were saying when they had to carry them out to the pickup trucks and load them and unload them. Quite the workout. But they got a free lunch out of it, so, you know. Did you get the same answer I did, Corey? That's a good sign. I wasn't supremely confident in my answer, so like, if a few people have the same thing I did, that's probably the right answer. If not, I probably messed up somewhere. Did you get the same thing?
I just had to double my answer.
Ah, so you forgot about the doubling.
Yeah.
Right, okay. Did you get the same thing? All right. At this point, we got 3 of us that agree with me, so I'm probably right. This is what we should have gotten. It's a lot of multiplication, right? But again, as far as thinking through how to set it up, does it make sense how to set up the equation? Now, if we had wanted the lateral area, we are not going to redo all this work, class. The only difference between lateral area and surface area is you don't include the top and bottom. Which part is the top and bottom, class? The stuff that doesn't have height, right? Sides always have height to them, correct? So whatever doesn't have height, that's the top and bottom. So that means the length width. This, if you take it out, leaves you with your lateral area formula. Does that make sense? So you don't really have to memorize 2 separate formulas. Just remember what isn't included for lateral area. For that matter, I don't have to redo all that math. I already did a ton of math, right? That's lots of multiplication, adding. I'm lazy, I don't want to do it again. All I have to do is, if I take that out of the equation, I also take this out of the answer. So now take 504 away from our answer for surface area. And what do we get for our answer? Call it when you've got it.
672 inches squared.
I got 678. 678 when you subtract 504. I think. Somebody else verify. I'm doing it in my head, so again, I lack confidence in this. Anyone else get 678?
Yeah.
Okay, here we
I
go.
got 768.
Yeah, I did too.
Oh, 760. I was dyslexic. I'm sorry. Yes, 768. Thank you. 768 inches squared. I told you I wasn't supremely confident in that answer. All right, do we understand how to work with surface area, lateral surface area? What about, you see those Rubik's Cubes that have little stickers all over them?
Yes.
And you can change the stickers. You know, that's the easiest way to solve the Rubik's Cubes. Put all the green stickers on once. I'm just kidding. You don't actually do that. But let's suppose we actually wrapped the Rubik's Cube. And, well, what would I use? I don't have time to actually work it because we're about out of time. But what's the formula for the surface area of a cube, class? SA equals?
6e squared.
Good, you squared. As that gives you one side multiplied by 6. What about the lateral surface area?
4e squared.
4e squared, because we just take away the top and bottom of the cube. It has about 2.5-inch sides, and that decimal is going to get annoying, and we're out of time anyway. All right, no homework this evening. We'll take a look at those quizzes tomorrow, see how you did. We'll continue talking about surface area, lateral area. Have a wonderful day. Hey, I was done before the bell stopped. Hold on.
Yeah.
Have a seat, because I'm still recording. I didn't cut it off like I meant to.
Yeah.